This is the EF Johnson Viking Mobile VFO. This is one or two of the rarest Johnson radio items made. I don't know which is more rare, this or the Navigator, but it's one or the other. This is quite a small VFO. This is not the Johnson 122 VFO. This is the Viking Mobile VFO, and it's quite small. It's about 4.5 inches square and about 6 inches high. It's got output on 80 meters, and it's got 40 meter output with harmonic taps for 2015 and 10. It's a 3-tube VFO, got an OA2 voltage regulator and a pair of 6 BH6 tubes. One is the oscillator and the other is a buffer multiplier stage with tapped coils for the harmonic output on the upper bands. It is rather unusual in the way that it is calibrated. It's got an SO239 output, and you make up a little cable. It's a little coax cable with a crystal holder plug on the other end to plug into your radio. It's got an octal plug on the back. It requires a common ground connection for the high voltage and filaments. 6.3 volts filaments. It can be wired for 12.6 volts if you jumper the tube pins and change the pilot light bulb. This one's wired for 6.3 volts, and it uses a B plus of 250 to 300 volts. It'll work on as little as 100 volts, but to get normal output from it, you actually use about 250 volts at B plus. Unlike some other VFOs like a Heathkit HG10 that only wants about 110 volts. There are two calibration adjustments. The lower one is for 75 meters, and the upper one is for 40, 20, 15, and 10. This hole in the back is to allow you to use an insulated tool like this to move the bottom turn of the coil on the main oscillator inductor L1. If you can't get the calibration in with these trimmers, you have to move coil turns slightly to get it calibrated. This one I will have to do that, and I'll show you how. This one with the trimmers, 3870 came up here at 3750, so it's 120 kcs lower, reading lower than the actual frequency, which is a glaring deficiency. So there'll be a different video on how to calibrate this thing. It's a rather tedious process because you have to open the things up, set things, close them back together, and open it up again until you get it right. It's made with a kind of a W-shaped chassis. This is one piece here, so the bottom, the top, and the front are one piece, and the two sides and the back are another that go together like that. And well, anyway, that's the basic deal. It does what every typical VFO will do. It gives you about 10 watts or 10 volts RF drive. You plug it into the crystal socket of any crystal controlled transmitter, and gives you a VFO. The calibration on this thing is, plus or minus about 3 kcs or so is about the best you're going to get on the low bands. and the high bands might be worse than that. The 15-meter output is unusual because it's 10.6 megacycle output for rigs that double to 21 megahertz. So in the 15-meter position, you're going to get 10 megacycle output. On the 20, 15, and 10, you're going to get 14 megacycle output, and either straight through on 20 or double on 10. Of course, it's straight through on 75 and 40, where most of us will probably use this thing anyway. The manual says it's not designed to be a precision frequency standard. You're required to use your receiver calibration and zero beat to really find out where you are. After we've gone through the calibration process, we'll see how good we can get the calibration to be and the tracking to be. But I don't have terribly great hopes for it. The stability seems to be pretty good electrically. It's not wandering a whole lot. The mechanical stability is a little something else. If you got listening with your BFO on the sideband mode in your receiver, and you start pushing on stuff, you can hear it, the frequency warble a little bit. So not going to be a good candidate to use as a VFO on your vintage sideband radio, but certainly plenty adequate for AM, where stability is not a great issue, and where you're going to use zero beating to set your frequency anyhow. Might as well look on the controls on this thing. It's very simple. There's an off position here, which apparently kills the B plus to the oscillator, but it does not turn off the filaments. The pilot light here will stay illuminated even the off position. That is normal. And so you're going to select either 80 meters, 40, 20, and 10, or 15 meters. And there's the frequency adjustment. That's all there is. And that's about all you're going to find on any outboard VFO anyway. I did fire this up, and it did seem to be pretty stable right off the bat. It didn't change an awful lot while it was warming up. In the context of a VFO that's made for AM use. So I think, you know, it's an interesting little package. The construction is fairly unique. It's built to be very compact, and they tell you if you're going to mount it in a car to put a U bracket all the way around it to support it well, because any kind of dimensional changes in the case seem to change the frequency some, because the frequency determining oscillator coil is so close to one of these side panels that when that side panel moves, it changes the inductance of the coil and changes the frequency of the VFO. This is just kind of what you get when you build something this small. If it was built in a die-cast aluminum case or a more rigid steel case, it probably would be less affected that way. But they did it. They did a good job, and it does what it's supposed to do. This is a 1953 technology, guys. This is 2023, so this is 70 years old. And you know, crystals are getting to be very difficult to get, and sometimes of very iffy characteristics and quality. So having a VFO is important, and I needed another one. I've had this for a while, and I finally decided to take the plunge and fire it up. I guess I hadn't done it because it had 6.3 filaments, and all of my mobile radios are wired for 12 volts, but I put it on an outboard power supply, and on the workbench to fire it up, and I'm pleased so far. And once I can get the tracking right, so the calibration is not all wonky, I think it's going to be very satisfactory.